Oh, okay, guys, look, I'm not feeling too well at the moment, okay? And for that very reason, if I mess up today, if I say something incorrect, or I'm not like 100% detailed when it comes to a topic, you guys gotta let me know, okay? You guys gotta correct me here, because if someone watches this stream and it turns out that I gave wrong definition for something, that's not only me being bad with revision, but you're obviously not going to do as well. So, let's get in with this. We're going to be doing a big overview of everything today. A big overview of chemistry, biology. We'll be doing some math questions towards the end, and we'll go quickly recap some English literature stuff. I'm going to move the camera back a little, actually, so you guys, there you go. So you get a decent view of the board and me. Okay. Let's start off then with chemistry. Now, we'll do chemistry, so I'll write right at the top. Chemistry, paper 1 we'll do first. And we'll do everything in chronological order. Okay. Number 1, let's do... Okay, you know what I haven't gone through yet? I haven't gone through the different types of bonds, I don't believe. And I'll go through them, but I can't... So, there are different types of bonds. There is metallic, which is a metal and a metal. Ionic, which is a non-metal and a metal. And covalent, which I believe is a non-metal and a non-metal. Now, I believe... Now, please correct me if I'm wrong here. I believe these are the things. So metallic bonding is a metal and a metal. And I believe that's intermolecular forces, the forces between. Ionic, I know this is true. Non-metal and a metal, and it's electrostatic. Because basically, you have a positive and negative in this formation, basically. And obviously that's going to opposites attract. So you have those electrostatic forces, and covalent, I believe, is just covalent bonds. But to be 1,000,000,000% sure there, let me actually go check my little mark scheme that I've made for myself here. See, I made a huge pack of flashcards here. If any of you guys want to borrow them or something. Okay, we'll do this one in a minute. Okay, ionic lattices. Electrostatic forces, we got that. Melting point and boiling point, they're going to be high. Because a lot of energy is required in order to overcome those strong electrostatic forces. Oh, simple covalent, I forgot about them. I believe simple is just non-metal and a metal. I believe. No, it's just two of the same element. So for example, it'd be like carbon and carbon. The properties of those is that they have weak intermolecular forces, which means they're going to have a low boiling point. Oh, and I guess you could also put that metallic conducts electricity. And I think ionic does conduct as well. Oh, oh my god, because of electrolysis. Holy shit. Yes. So actually, ionic does conduct electricity, but only in molten or aqueous form. Electrolysis. Polymers. Oh. The properties of polymers, I'm going to assume that this is purely based off the chain length. So if you have a long chain length, it's going to be strong bonds. If you have a tiny chain length, it's going to be weak bonds. Yeah, so it's intermolecular bonds. It's actually a subsection of covalent. It's actually part of covalent bonds here. Polymers, that's pretty cool. Giant covalent, I mean, yeah, strong covalent bonds. They have a high melting boiling point, and they can conduct electricity only if there's leftover electrons. Properties of metal, it's going to have strong electrostatic. So actually I've got that wrong there. That's also electrostatic. High melting and boiling point, and they do conduct electricity because they have a sea of delocalized electrons. Alright. Here's a good question. Where's my little tea towel gone? Here's a good question. Why does group 1 become more reactive as you go down? Well, if we look at it logically, you have 1, 2, let's say we have like... Sorry, in fact, no, we can still make this, right? If we draw another one and make that one, why do they become more reactive as you go down? Well, it's because this electron is further away from the shell. It's being shielded, and that's an actual term, shielding. These electrons are shielding it. And because it's only one electron, it means it's going to be a lot more unstable, and less energy, less force is required to make it go from here to make it react. Less energy is required. So a proper definition here is all the elements have one outer electron, which is what I've just said. So they only need to react one electron to react. They only need to lose one, not move. So as the electron is further from a nuclei, it has less attraction. We've said that. And also, it is easier to lose an electron. So there's less attraction between this positive mass and this negative mass. Less attraction, which means that it's going to be lost way easier. All right. Let's go do. So we've just gone through structure and bonding, chemistry. What else do we go through now? Let's go through electrolysis. How about that? No, let's go through crystallization first. You guys know by now, because I've gone through this on every stream, the step-by-step process of crystallization. Firstly, you need to get your acid and your oxide. So for example, if we're making magnesium sulfate, it would be sulfuric acid and magnesium oxide. So what you would say is you would firstly add your sulfuric acid to a beaker, heat it up. You would then add excess magnesium oxide, or basically keep adding until there is only this remaining, until there's only magnesium oxide remaining. What you would do from there, again, I'm not feeling too well, so if I do make a mistake here, just please let me know. You would filtrate it, because if it's excess, you want to get rid of the excess solid. You then want to evaporate it, and then you want to leave to crystallize. And after all of that, if you're making a pure dry crystal, you can pat it down with a cloth to remove any excess, I guess, liquid. So that's the step-by-step process. And obviously you would have to explain why, I'm assuming. So why would you heat up a beaker with acid? Well, when you heat stuff up, the particles, I don't know why I drew it like that, the particles are going to move around quicker, which increases the likelihood that they collide. It increases the rate of reactions. Okay. What next? Let's go through... Neutralization, I guess we'll go through. Okay, so neutralization between an acid and an alkaline. You have H plus, OH minus, and you get water. Now that is your acid, And the definition of an acid is that it dissociates in water to give hydrogen plus ions, and OH minus is an alkaline because that partially dissociates in water to give OH negative ions. And together their product is H2O, water. Do summit work even if you don't know it. What are you on about? So that's neutralization. Now you could, I guess, go even further here. You could actually say that H plus is just a single proton, but I don't think you need to know that. I'm trying to think what else you need to know about. No. So, there you go, guys. We've just gone through structure and bonding, crystallization, and a bit of neutralization. Let's go change to... Is there anything else I can go through? Okay, let's move on to chemistry paper 2. The tests. These could be worth in your exam up to 8 marks. Okay? Up to 8 marks. Maybe between both papers, maybe 10, 15. We have, first of all, haloid testing. Or group 7. Now, what will we use to test for haloids? You would use silver nitrate. And as a result, you're going to get your white, cream, and yellow precipitates. You're going to get your white precipitate. Oh, this pen's just gone dead. You're going to get your white precipitate from chlorine, the first group 7. Second group 7 is bromine. And your third is iodine. So there you go. That is halide testing. Next, flame testing. Flame testing you would use for a nichrome wire because it's unreactive. You would place it in the blue part of the flame, the hissing part of the flame, I guess you could say. And depending on what metal it is, so remember, you dip it in your metal solution. Depending on what metal it is, depends on what you get. So for example, potassium is purple. Sodium is yellow, I believe. Lithium is red. And copper is green. Let me just go quickly check, because there may have been a tad misconception there that I may have just said. Let me go check. Where is it? Oh, I can't find it. Okay, well, that is kind of weird. I can't find the set of flashcards, which means you guys are going to have to trust me there. If you guys know whether sodium is yellow and lithium is red, let me know when they react in a flame test. The final one is hydroxide testing. Metal hydroxide testing. For this, I think you use sodium hydroxide. What you would do with that is you would add some, and then it works for aluminium, magnesium, calcium, iron 2, iron 3, and copper. For aluminium, magnesium, and calcium, it's colourless. No, sorry, it's white. So for those three, it's white, but if you add excess to aluminium, it becomes colourless. For iron 2, I believe it's green, and for iron 3, it is brown. I may have gotten those mixed up, so please check. Again, I'm going to put a big star next to these there, because I can't verify if I've done those right. Copper, I know, is blue. So guys, if you know this yourself, let me know. Let me know. But I'll give you guys just a second if you want to copy any of this down. Halide testing, flame testing, and metal hydroxide testing. Let's go quickly do the 4 most basic tests. How do we test for chlorine? Chlorine turns the litmus paper bleach, or it bleaches litmus paper. What about carbon dioxide? How do we test for that, guys? Do any of you know? If you've watched any of these streams in the last couple of days, you should know this. I'll give people 1 minute. In fact, let me go message Kieran, because I think chat's pretty dead. I'll go quickly message Kieran and let him know. Okay, I'm back. I just messaged Kieran, let him know, and I put it on Instagram. Guys, seriously, if you watch these for even 10-15 minutes, it could really help you. So anyways, let's continue. So carbon dioxide testing turns lime water milky when bubbled. But what's a better way of saying that? Well, you could say that it produces a white precipitate. A white precipitate when bubbled through calcium carbonate. I believe that is the name for lime water. Calcium carbonate. So it creates a white precipitate of calcium carbonate. The other two are really basic. For example, oxygen testing. It relights a glowing splint, and hydrogen testing, it combusts or it burns with a squeaky pop. So if you put it in a test tube, which is producing hydrogen gas, it will give off a squeaky pop. Let's go to electrolysis. I know Bobby absolutely despises this, but it is a tough topic, which is why I'm teaching it, because if you guys can understand it, it means you're at a huge advantage to the millions of people in the country that don't understand it. So pay attention. Remember hang on guys, before I even draw anything, remember the 2 acronyms, and from that you can pull a bunch of information. Okay, look, PANC and OILRIG. Pank or panic and oil rig. Okay, look. Positive anode, negative cathode. Oxidation is loss, reduction is gain. We now know a shit ton of information. You might not think it, but we now know a lot. Number 1, we now know if it's positive and negative, we know that this is taking place ionically. It's taking place in an ionic lattice. From just the simple fact that you should know it, it takes place in an aqueous or molten solution, and that is so that the ions are able to move around. We obviously know oxidation is loss, which means that happens, oxidation must happen at the anode, I believe. And reduction should happen at the cathode, so it's negative. All of that information, but we can go further. When it is in, electrolysis causes the ionic lattice to break down. Remember how we remember that? Luke Kelly messaging me, break down. What else can we gather? Okay. Well, we can gather the fact that electrolysis obviously must happen between a metal and a non-metal. If we were extracting bauxite, if we were extracting aluminium from bauxite, remember bauxite is just aluminium and oxygen. What's our product there? What do we need? We need aluminium. So you put in 2 anodes and you surround the rest with a cathode. Our electrolyte here, this thing here, is going to be obviously bauxite, molten bauxite, because it needs to be in a molten solution. Specifically for extracting aluminium, you would need cryolite, molten cryolite. Okay? So you would add your molten cryolite, which reduces the overall melting point of bauxite. You would then pop your stuff, and the oxygen would of course go to the positive anode, and your aluminium would go to the negative. Now one question you could get asked is, why the flippity dick do we need to replace these constantly? Why do we need to replace the anodes in something like this? Well, if you think about it, oxygen is going to these anodes, and these anodes are made out of graphite. Graphite is carbon, so it creates carbon dioxide, which causes it to weather down. And that's it. That is everything you need to know about electrolysis. If you can remember that, half equations I think are fine, honestly. I'm not too sure about them myself. We haven't gone much through them, but I think that's it. Let's go through organic chemistry, which is a favourite of mine. We have alkanes, alkenes, alcohols, and carboxylic acid. Okay, so let's break each one down. Alkalines don't have anything special with them, okay? They're completely generic. This would be an example of an alkene. Alkane, sorry. And remember, each carbon can have 4 bonds. It must have 4 bonds, alright guys? It must have 4 bonds. You do understand that, okay. Alkenes are slightly different. They have a double carbon bond, which means you actually don't need as many hydrogen. Now we'll get back onto alkenes in a minute. Alcohols, they have an OH, so it will be C, OH, H, H. And carboxylic acids have COOH. So C, OH, OH. So, you can draw a carboxylic acid, such as ethylene acid, I don't know what you call it, etholic acid. You can draw this like that, because it's an acid, and remember, acids partially dissociate in water, sorry, not partially, they dissociate in water to give a hydrogen plus ion, H plus, which means the H plus goes there. So COOH. Alright, what else? Well, alkenes, if you wanted to test for one, I believe you would use bromine water. Think it's bromine water. Because basically, what the bromine would do if it was an alkane is it wouldn't react at all. It has, look, carbon has all of its bonds. It literally can't do shit, okay? It can't do their shit. So it doesn't do anything. It will change colours because you've added it in, you've added the bromine in, so it's going to change colours, but it won't do anything. It'll just change colours. If you add it to alkenes, it severs the bond, it severs the double carbon bond, so you can now have 2 extra bonds. And as a result, it will change colour, but then it'll go colourless after a while. That's how you tell the difference. Alkenes will go colourless, alkanes will stay the exact same. Next, to go from an alkene to an alcohol, you need to, oh sorry, I did that wrong. You need to sever this bond here and add an OH and a couple of H's. So you would add water or steam. It needs to be obviously scalding water. So you would add steam and you would use a catalyst, and I'm not sure off the top of my head what you call it. It's one of those like funny elements. I think it starts with a P. I can't remember. I cannot remember. For the love of me, it's... I think it starts with a P. Bollocks. Okay. You would add a catalyst, and it's on the... I can visualise it, but I don't know the name. Oh, this looks so bad on me, but I don't know it. I don't know it, but in order to go from an alkene to an alcohol, you would add steam and this mystery catalyst. The name will come to me when I least expect it. And I don't know how you would go from an alcohol to a carboxylic acid, but I guess you would add a double bond there, and you would add a oxygen. So I'm assuming maybe you would do something similar, like maybe CO2. That kind of sounds right. Anyways, that's all you need to know. Obviously, you can remember the acronym Monkeys Eat Peanut Butter. That is a very goofy sounding acronym, but that's used to tell you the first 4 types of hydrocarbons. MEPB. So you have MEF, EF, prop, and boots. So for example, methane, ethane, propol, that doesn't sound right, propolic, I don't know. Either way, that's it. That's all we've gone through in terms of that. Unless there's anything else I can think of, but we've gone through in detail with our chemistry teacher so far. I think that's it. Chemistry of the atmosphere, we could go through quickly actually. So you could talk about why is the planet heating up, or you could talk about, let's assume this thing here is our little atmosphere. This is our planet. I'm just going to write OK in the planet. So short wavelength, infrared waves are going to go in. They're going to get absorbed by the planet. And as a result, it's going to release long wavelength infrared, which may be blocked, I believe, or something blocked. I don't know the exact term, but in other words, the atmosphere will absorb some of that radiation that the Earth has released, causing the planet to heat up because it's getting bounced back. So it's quite an interesting little process. Now, in terms of the early atmosphere, you could talk about how, okay, so let's so the early planet is just about a shit ton of water, you know, a shit ton of water. How come our planet went from being a shit ton of CO2, methane, and what's the other one called? Ammonia. How come our planet went from being a shit ton of that to what it is today, where it's oxygen, nitrogen, a tad bit of CO2, or I guess you could just say pollutants, trace pollutants, and what's that one? Argon. How come our planet went from that to that? Seriously, guys, how did it do that? Well, you could talk about the fact that the CO2 was absorbed into the ocean, and green algae used the CO2, photosynthesized in order to create oxygen. You could talk about how some of the CO2 would be used by shells, by plankton. When the plankton die, it would go into the seabed, And as time would go on, they would pile up, and eventually they would kind of get buried. The warm temperature would prevent from decomposing, so they're now trapped underground. The carbon is locked underground as a sedimentary rock. You could also talk about, I guess, literally just the CO2 getting thinged by the water. But I think that's it. That would be a 6-mark response. You talk about green algae photosynthesizing to create oxygen. You could talk about the carbon locking. What else about chemistry of the atmosphere? I guess that's kind of it. It's a relatively generic topic. You could talk about like water and how that came from like comets and shit. How the harmful gases were caused by volcanoes. The consequences of global warming. You could say how it causes damage to ecosystems due to the fact that the rising temperatures will cause ice caps to melt, rising sea levels. You could talk about how... Oh, I guess you could... Oh shit, I've drawn on my trousers. You could talk about how there's different pollutants. Sulfuric acid, I can't remember exactly. So like you could talk about carbon dioxide, which is caused from like incomplete burning of fossil fuels. You could talk about how sulfur trioxide combines in the atmosphere with water vapor in order to create SO4, sulfuric acid, which is acid rain. You could talk about carbon monoxide, which obviously binds with the hemoglobin in your blood. You could talk about that, and it slowly suffocates you. Methane, which is like cows, and that causes like global dimming, I believe. But that's it. We're done with chemistry. I've just gone through that. What? 1, 2, 3, 4, maybe 6, 7 chemistry topics. In the span of about half an hour. If you guys even clicked on halfway through this, you still would have picked up a bunch of marks there. We went through neutralization, crystallization, electrolysis, the chemical test, which again, a lot of marks from that. We went through some exam responses and some general knowledge. So there you go, guys. That's the chemistry section done. Let's do biology. We'll start off with... mitosis. Mitosis, how does that happen? Well, if we look inside the nuclei here, the chromosomes will replicate, the nuclear membrane will break down, the chromosomes will line up in the middle as the nucleus replicates. They are pulled by fibers to each end of the cell. And then from there, the cytoplasm and the cell wall replicate, giving you 2 identical sister cells, or daughter cells. I think that makes more sense. So that's mitosis. That's literally it. It took me 30-40 seconds to do that. If you have to explain that in an exam, there's some annoying keywords with mitosis, like interphase and, I don't know, metaphase. I don't know what they mean. All I know is that I learnt from BBC Bite Size. I've remembered that very well. So that's my way of remembering mitosis. If in an exam it asks you to define a certain phase, just think about it. Just think, okay, hang on, interphase, that's the phase where nothing happens. That's literally a intermediate phase. Anyways, so that's mitosis. What else can we go through? Let's go through the heart quickly. So if I draw my heart like this, which Mr. Hooper has done quite a bit because me and him can't draw hearts. So these are the atrium. These are the ventricles. Okay. So you have your atrium first, it goes into the ventricle. Coming out of this side, Shit. Hang on. I think this is it. Okay. You have aorta. You have vena cava. Something's wrong. I've done something wrong here. I've drawn one of the arrows the wrong way around. Because this is meant to be the pulmonary vein. I think this is meant to be the pulmonary artery. Let me go check. I've forgotten to draw the arrows. I've done the arrows the wrong way around, and it's messed up my train of thought here. Ha! Okay. That's your vein. That's your pulmonary artery. This is your pulmonary artery. That thing there. That is your vena cava. Okay, in case you were asked to recite any of that. The way I remember it is pulmonary artery goes out, literally goes out. Aorta is just kind of a funny name. Pulmonary vein going in, and vena cava going in. It's just a random ass and goofy name. Anyways, digestion. You could talk about mechanical digestion from your teeth. You can talk about chemical digestion for your salivary glands, which create enzymes which break down food. You can talk about your esophagus and how that squeezes the food, which is mechanical digestion. You can talk about in your stomach, the pH of your stomach acid is 2 because it's hydrochloric acid. You have a stomach lining to prevent the acid from spilling out and burning you alive. What else? Your stomach, obviously, chemical digestion. Your small intestine contains villi, which are kind of like these things. Your large intestine removes the water from the food. And that's basically it. So let's go on to the villi, which in your small intestine, they have a lot of capillaries. And these capillaries, allow for a constant blood flow or a strong diffusion gradient. Because remember, the ions, blood, the sugar, I think it's sugar. I could be wrong about that, but let's just say the ions are the molecules. The molecules are going in to the capillaries and then going around your bloodstream. So they need to diffuse in. They have a large surface area to allow that to happen more. They have cells with a lot of mitochondria for active transport. So if they want to get sugar out. And you could talk about as well being one cell thick so that, ions can go in and out. Similarly, I don't know how you say that word. I have a lisp or something. In your lungs, you have alveoli, which are like air sacs. And you could talk about almost the exact same things. You could talk about how they have a large surface area in order to absorb more oxygen. You could talk about how they are moist in order to obviously absorb more. You could talk about how they are one cell thick. You could talk about how there are like capillaries nearby. Basically, copy and paste response. Next, so we've just gone through the heart, the digestive system. Let's go do the other quite tough thing, and then we can take a breather, go through some easy stuff. The different tests, you have sedan-free, you have Benedict solution, iodine solution, and burette solution, or I don't know how you pronounce it. Burette, French or something, I don't bloody know. Anyways, Benedict solution is used to test sugar. Iodine solution is used to test starch. Sedan 3 is used to test lipids, and Burex is used to test protein. Why did I spell it like that? Benedict solution, you need to put in a hot water bath, because that allows, I assume, like, rate of reactions to speed up. All the rest, you literally just add a couple drops of the solution, give it a shake, and something will happen. In the Benedict's case, it'll go from red to green, depending on how much sugar there is. So it's literally like kind of, you know those like labels you get? Oh, hang on. Whoa, sorry, I don't know how much of that you guys picked up. You add a hot water bath to the Benedict solution. It goes from red to green depending on how concentrated it is, with red being the most. So you know, like at Asda, you get like those little labels where it's like, red is a shit ton of sugar and you shouldn't eat it, but green's like, oh, that's a canny, you know, that's alright. Iodine, black and blue, depending on, obviously, the starch quantity. The way I remember Benedict is it's kind of an odd one out, because you need to actually do something with it. You give it a water bath, and it just red to green, because remember the Asda labels. The way I remember the iodine solution is Kieran wrote a brilliant bar in a biology lesson where he said, I'll be treating you like starch, I can't wait to make you black and blue, something like that. And I just now remember iodine solution, starch, black and blue. Sedan 3, the way I remember that is 1, 2, 3, and lipids has 3 kind of elongated, you know, L-I-I, so that's kind of how I remember that. 3 elongated letters. So Sedan 3, and the way that works is a mixture on the top, a solid at the top will be red, and it will separate. So if your thing contains lipids, it will go red right at the top. Finally, Burex protein goes purple. The way I remember that is purple protein. So those are the food tests. Guys, give yourself a bloody breather now. I know I'm gonna. Because that was quite a lot. So you guys should be very, very happy. Now a question I'm gonna get, maybe, is, hang on Joseph, what the fuck, you're going through this way too quickly, I don't understand anything that you're chatting on about. Okay. 2 words. Google document. I have a Google document where I literally get everything that I've revised, pop it on there, along with some exam question prompts, also just some keywords and maybe a couple answers. And that, for me at least, is enough to stimulate a response. So if I'm thinking, okay, food tests, I scroll to the food test section, I look and I think, hang on, purple protein, lipids, Sedan. And then from there, I can think, okay, Sedan is the one where it separates from red. Benedict's is the one where you need a water bath, it goes red, orange, or green. That's enough for me to stimulate a response. For you guys, it might not. That's why I've included key terms. That's why I've included links to all of the past streams on the subsections that you need. So if you go to like the organic chemistry section, it'll link you to stream number 6, where we went through organic chemistry in a lot more detail. I'm just doing a big overview right now, okay? I'm doing a massive overview. I'm not taking much time to dive into deep detail. So if you guys want some detail, go on the Google Doc. So we've just gone through all of the chemistry shit, all of the biology stuff. Physics, again, I just don't care about physics, I'll be honest with you. There's only 2 practicals I remember about physics. Number 1, which it's so boring, I don't even want to like talk about it. But it's for one where you are testing the strength of an electromagnet. You guys already know how to do that. It's higher content only, so you guys might not even need it in your exams. Oh, why is my head doing that, bro? But the other one is actually alright. It's testing the density of an unknown object. I'm not even going to draw this out. It's so basic. Okay. Measure the mass of it. Okay, so let's say we're testing the density of this object, this irregular object. To measure the density, you would first use a balance in order to get the mass. So let's say it's like 50 grams, okay? 50 grams. How will we get the volume? Well, in order to calculate the volume, you would fill up a eureka can, I believe that's what you call it. You would fill up one of them right to the top with water until it reaches the spout. Okay, maybe get some water to drip out to make sure it's exactly even. Then you would gently place the object in to that eureka can, and you would collect all of the displaced water in a displacement can. You would then be able to obviously find the volume of the displaced water, which is the volume of your object. So let's say it's 100. Let's say it's 100 milliliters. So there you go. You now have the mass. You now have the volume. Density is mass over volume. MDV, my dad's van. You know, there you go. So the density there would be 0.5 grams per milliliters cubed. Or something like that. Centimeters cubed. But honestly, I'm honestly just so tired, guys. That's why I'm barely explained that one. But you guys already know how to do that one. So there you go. We've gone through physics, we've gone through chemistry, we've gone through biology. If any of you guys have any questions, now will be the time to say. But remember, the Google Doc has everything you need. I know every day, that I'm doing science revision, I will be adding to that Google Doc and I will be using it extensively the night before the exam. Obviously, I won't be watching my revision streams because I know the content myself, but, you know, you guys could. But remember, this is just me, right? This is how I find revision to be helpful. I used to enjoy doing past papers, but what I found was that for science and math, if you don't understand how to do it, you won't be able to succeed at past papers, okay? So, for example, in chemistry past papers, I would do 5 questions, check the mark scheme, I would get every single one wrong, and I would think, well, this isn't helpful. All I'm doing here is memorizing a mark scheme. So what I started to do was not do them. I would just literally just pay attention more in class, and boom, now I know a shit ton of content and the mark scheme. All right, let's do some math. All right, guys, factorization using the AC rule. This is my favorite thing in math. It is. I love it. It would be shit. I can't remember how you would format this question. Okay, similar like this. We need to put this into brackets. 5x squared plus 20x plus 4. How will we put this into brackets? Well, this is A, this is B, this is C. What's A times C? That's going to be 20. We can't do this. We'll put this as 9x instead of 20x. Okay, so there you go. So 5 times 4 is 20. And the middle number is 9. So what two numbers multiply to give you 20 and add to get 9? Well, that's going to be 5 and 4. Alright, so now we have 5x squared plus 5x plus 4x plus 4. Now we can do some good old double brackets and find the common factors. 5x squared plus 5x, that would obviously be x plus nothing. Right? No, x plus nothing. Because what you'd have on the outside there would be 5x. And on the outside of this one, it would also be x, and that would just be 4. So in conclusion, your two brackets are x and 5x plus 4. That's the answer, because x times 5x will be 5x squared. 4 times that would be 4x. I think I must be missing something here, actually. I honestly don't know how to set up these questions. All I know is how to do them. So that, I think I could have got the wrong answer there, but I know how to do it, okay? Anyways, complete the square. I know how to do that by clockwork, so I won't do that. What else? Expanding triple brackets we could do quickly, and then I'm heading off. No one's watching. This is a waste of my time. X squared plus 5, x minus 3, 2 plus x. Okay. We do the cup rule, or I don't know what you call this, but we have x cubed, 5 times minus, oh, I've done this the wrong way around, sorry. X squared minus 3, 5x and minus 15. So those are our terms, and we would put the bracket in, so 2 and x. That would be 2x cubed. That would be 2x squared minus 3, I think. That would be 10x. That would be minus 30. That would be x to the power of 4. That would be x cubed minus 3. That would be 5x squared. That would be minus 15x. Now, we can cross all these out and collect our like terms. Anything with x4, there. Anything with x3, 2x3 there, and minus 3x there. So that would be x cubed, right? 2x, no, minus 1x cubed. Oh yeah, it would just be minus x cubed. So, sorry about that. Okay. Then anything x squared. So we have those two, so it would be 7x squared minus 3. Oh, I've done this wrong. It would be minus 6. Minus 6, and then you would add 5x squared, so that would be minus x squared again. Oh jeez, I've done this weirdly. This is a horrible equation. Anything with x on, so that would just be 10x. And anything with, oh no, sorry, 25x, because you would have that. And then anything just with a number there. So that answer there, x squared plus 5 times x minus 3 times 2 plus x will get you x to the power of 4 minus x cubed minus x squared plus 25x minus 30. That was a horrible question. I made it really bad for myself there. I shouldn't have done. But hey, that is worth like 6 marks in an exam, maybe 5, which is pretty neat. That's it though. I think that's everything, guys. Seriously. I've gone through a bit of math, but I didn't explain it that well, because seriously guys, it's warm in here, I'm getting tired, I'm ill. So my big apologies if I did say anything wrong, did get anything wrong. I don't think I did for the math bit. I missed out 3 things from chemistry. 3 things. I think it was phosphorus as the catalyst for that thing that we did ages ago. I'm done now though, guys. Seriously, I'm done. I'm tired. Probably gonna go play Terraria and chill now because, yeah, that has been tiring. But there you go, guys. We just went through some mental revision there. We went through a shit ton of chemistry, a shit ton of biology, a tad bit of math, tad bit of physics. English, I can't be bothered. I'm too tired. But there you go, guys. You have probably learnt more in this whole hour than, I don't know, a month of Mr. Hooper. Let's be honest.